So what we're going to talk about today is JavaScript and go through a progression of some of the key points and things that have changed, and hopefully what does it mean by modern web development, and people don't even call it that. They call it modern JavaScript development. So it's something to keep track of. So JavaScript landed in around 1997, but we should understand that there was other things going on before then. And so, there was this era before JavaScript. And so we had browsers and we had HTML tags and that. But a big thing was Java applets. And you could have rich internet applications, that's RIA, because that's what people talk about today, building rich internet applications. But we had these a long time ago. Your browser did need a plugin to run the Java applet, but as long as it had the plugin or Java installed, it could typically run the applet. And we had full-fledged GUIs, canvases that could be drawn on. So back in 1996 at a Geotech conference in Vancouver, there was a presentation from, I guess, Land ADBC, McDonald Detweiler was the contractor, and they demonstrated a Java applet basically where you could actually look at data in our data warehouse and that. So all of this was available. So menu systems, different types of buttons, radio buttons, checkboxes, you name all the basic GUI controls. We had all that running in browsers on top of existing web type controls. So it was already there. We had already solved the problem. But what you find is that we have a tendency to solve a problem, then unsolve it, then solve it again, and then unsolve it. So there were a lot of technologies on the back end that could spit out HTML, CGI, Common Gateway Interface. You don't even need a web server, and you still don't today to make HTML come flying out of a server. But Apache was popular, IS was popular, and definitely PHP as a web programming language for the back end was very popular. Not something that happened up in the front end, up in the browser, but definitely in the back end in that. And of course, there were improvements to CGI to speed it up, fast CGI. But a big thing we should talk about is that Oracle existed, for sure. There was lots of data in there. And they bought a product. It was developed outside and then bought by Oracle called WebDB. So we, way back then, could have web forms in browsers, capturing data for the database, and presenting or reporting on data that was in the database. So all the same stuff that we're trying to do today, solved, okay? And then we needed to unsolve it, okay? And so what we're talking about is, when we talk about JavaScript, in this part, we're talking about JavaScript running in a browser. So at the time, it was just desktop, right? No phones yet, no tablets, no game consoles. But when we talk about this style of JavaScript, we're talking about JavaScript running in the browser. Because later, we're going to talk about JavaScript running in other places. So this is basically the ECMA script standard, versions 1 through 3, right? So we have the script tags show up in HTML. Try catches get implemented, structured error handling. They're borrowing that. They see that over in the Java side. And so they wanted to have something similar. They had switch statement. This is back, in the late 90s. The switch statement is just arriving in Python 3.10. And that's more from resistance. They have to know how to do it in that. But it's just arriving in 3.10 and probably won't be available in Arc Pro for a while until they actually upgrade Arc Pro and raise up the level of Python that they have to 3.10 or higher. Interesting, I threw regular expressions on here because they seem to show up, I guess, everywhere. They got migrated into Java, they get migrated into the databases, they get migrated into all these different areas. People just seem to love them in that. I'll mention Flash ActionScript. So Flash is pretty popular for doing interactive web applications. I mentioned ActionScript because it is one of the languages under the ECMA specification. So today we would, I guess, put in there JavaScript, of course, JScript, ActionScript. We might even sneak in QML in there as well. It does a little bit more than JavaScript. It can definitely do what JavaScript can do. Now there's lots of other stuff happening in the back end. So PHP is a mixture of HTML and a coding language. So JavaScript, or Java server pages, here, this is in the back end. So this is the back end web tier, not up in the browser. So in the back end, the part of the stack that would talk to the databases and pull data out and then ship it to the front end was typically written in Java server pages, which is a mixture of HTML and Java. So you just swap out the programming language. ASP.NET, again, you swap out the programming language. ASP, probably VB script or VB. In ASP.NET, we're talking VB.NET and C# and that. But basically, it's that mixture of HTML and code all in one place, and we can then take that HTML and ship it to the browser to be displayed. MySQL and Postgres show up on the scene as database alternatives, open source ones, that could also be used for storing data for web applications. MySQL, very popular in the beginning part of the web in that. But if we zoom up into the 2000-2009 era, right, this is sort of a strange time, right? ECMA 3 had already been published a long time ago. They're trying to get a version 4 out. Again, this governs what's possible in the JavaScript language. The developers know, hopefully, what's possible in the language and what a browser should be able to do. And then they can write applications based off those assumptions. But it never got released. It just took too long to get there. By the time we got there, there was a new focus, HTML5. But we'll just go through there. There are some big parts that kind of happened in this time that sort of got adapted or adopted by a lot of the browsers, whether it be standard or non-standard. XML and AJAX was big. That's the browser, AJAX, doing an asynchronous JavaScript call to the back end, typically to get XML data. So the data is coming out in XML, so it's very, angle bracket like HTML. It was easier for people to look at XML and go, it's kind of like HTML. It was way better for structuring data than HTML itself. HTML is more about the presentation of the data. XML is more about the structure. There's all these schema documents that you could get when you move data out of the database that would have all the rules. Hey, this is a number. This is a date. This is a number between this range. This is a primary key column that has to be unique. So that the whole idea is that when the data finally comes back to the database, it can get checked in okay. It's not breaking all the rules. A big thing that happens here, but is kind of subtle, is JSON shows up as well, or it gets specified. The concept of storing JavaScript objects as text in this JSON format. And so although it got started here, I wouldn't say this is where it started to dominate over XML. XML is what was used to build a lot of the services that we'll talk about, and so when you talk to those services, what would come out of them was some type of XML. Could be something like GML, Geographic Markup Language, or maybe it was KML, Keyhole Markup Languages. Google Earth, all those products were very popular based on their ease of use. Now we'll talk a little bit here about Flex ActionScript. So Flash moves to Flex. And the only reason I bring up this technology is because of the ActionScript language and how it's also governed by this Emacs spec. One thing is that our services were SOAP XML in the background, right? Simple object request protocols. So you talk to the server, but what always comes back is XML. So ESRI had even before ArcGIS Server had ArcIMS Server. It had their own language called Axel that would send XML back to the browser. If you flipped it to debug level 3, you could actually see the XML coming back from the product that would come into the browser. Then the XML needs to be chopped up, extract all the values in it, and then do something with it. But ArcGIS Server, the very first versions that were there to replace ArcIMS were SOAP XML web services. There were proxy objects that you would go to the service. I think it was a WSDL. It's called a WSDL file. It describes all the objects that are in the service and how to make them on your end so you can talk to the service. And then you can pull data out. Now, OGC services are typically built in this style, but they've been upgraded so you can say instead of giving me GML, right? So a web feature service, WFS, when you ask for features out of it, by default they'll come as typically GML, a type of XML, but you can actually today ask for it as GeoJSON in that. But these services all got built. They're still out there. We'll interact with them in the course. So there's still people who can quickly publish a web mapping service in OGC format. And it uses this older way of requesting data. And it's not bad. Older just means there's less bugs and is pretty well guaranteed to work in that. And working is always good. There's other technologies that start to show up. Java server faces. So this is really about a lot that was in there was like dynamic routing like we see today. And that's also breaking the page up into, I guess, more components that can be updated, even though it was Java on the back end. Java server faces, a lot of the front end controls were JavaScript based. Okay. And the Nginx showed up as well as a new web server that became popular. It's still popular today. It shows up in a lot of Docker containers, and so it hasn't gone anywhere really in that. But the version 5 of the script, roughly around 2009, is where HTML starts to finally settle down in that. So lots of big players, Microsoft, Facebook, Google, Twitter, and all that. And we finally get the standard kind of settled and published. And this is kind of important. This is where in the previous era that didn't get published, it was really a browser battle where the world thought one browser would take over the world, right? So it was Internet Explorer dominated, then Chrome came up and dominated. Firefox was in there for a little bit. But we're moving away from that concept that a particular browser is going to be the thing that everyone on the planet uses. What's happening now is that the spec is starting to take over. The spec moves forward, and then the browsers rush in to support the spec, which is great. What it means is that there's less, I think the term is called transpiling of files. So you write an application and then it gets translated in a version that works with Edge, that works with Chrome, that works with Firefox. That still happens today because not every browser is 100% compliant with the spec, or they implemented it slightly differently, and so it gives you a slightly different behavior in the browser. But this is probably where the ECMAScript standard starts to dominate over any particular browser, and the browsers are a layer below or above, but it's the script but it's the standard that's starting to drive things, which is not bad. Okay, we get other things that are happening are like CommonJS shows up with a required statement. This is trying to add imports to JavaScript. Applications are getting bigger. So the concept of importing code from modules exists in VB.NET, Java, C#, Python, but it's not officially there according to the ECMAScript, not yet anyway. And so people said, well, we need some sort of facility like this, right? That my JavaScript requires these other JavaScripts. Go get them and bring them in. Okay, and so it's kind of like an import statement. When we get to the bottom of this slide, we'll see, or section, we'll see where Node eventually pops and becomes very popular. One thing that's really important, even though JSON, JavaScript object notation as a concept has existed for a while, the spec says that every browser needs to have a JSON function in it. So that's the JSON with the parentheses over here. Really important. That means that you as a developer can count on the fact that there will be something that can parse JSON. That if you go get JSON from a server, GeoJSON, whatever the JSON format is, there's going to be a function in whatever browser the end user is using that can parse that big chunk of text and turn it into real JavaScript objects and arrays that you can use. Okay. Another reason to jump back to require, another reason I mention it is because the ArcGIS 3 API uses a lot of require calls to pull in the JavaScript code to support things like geometry, points, polygons, different types of layers, the map itself, web workers, and that sort of thing. And so where you might bump into ArcGIS 3 APIs if you're using something like Web App Builder, doing 2D apps in Web App Builder, I mean, it still exists in ArcGIS Online, so you can still bump into the 3 API, and you will be required to use the required statement. Okay, 2008 is where we get HTML5. That's where things, I guess, settled down from the previous area 4, where we're really in the browser war era, and now the spec is starting, the ECMAScript standard is starting to dominate over the browsers a little bit, is one way to look at it. A big thing that happens in the middle tier is REST JSON. Huge. So it's a switch from SOAP XML, right, to REST JSON, that the service will be shooting out JSON. And we're guaranteed to have a function in the browser called JSON that can parse it. That's why some of this works and can be adopted so quickly. ArcGIS server services move off of SOAP XML. They moved early, and they are REST JSON services. When you go to those types of services, hosted feature service, let's say some type of vector layer, and you query it, you're going to get it as ESRI JSON. You can also today get it as GeoJSON or some type of protocol buffer format, which is like a binary version of the above. Okay, a huge thing that hits in this era is Node. Okay, so Node is doing JavaScript not in the browser, but in the back end. So instead of doing PHP or JSP or ASP or Java Server Faces, JSF, which is a different programming language than you would use up in the front end of the browser, you're actually doing JavaScript on the back end. Okay, what made Node possible was someone looking at the Chrome browser and saying, that V8 engine they use, right, for parsing JavaScript, I could almost use like the Python interpreter, right, and interpret code on the back end. So where Node picked up steam is building back-end web servers, right? But because the V8 engine acts like an interpreter, much like the Python interpreter interprets your code, Node type technology like this is not restricted to a server. It could be used to build desktop applications too. So that's something interesting that happens in the future. Because when people say modern web development, right, sometimes they don't even say that. They say modern JavaScript development. And then you might go, what happened to the web part? Well, maybe we're not doing web front end in the browser. Maybe we're doing back end stuff. Maybe we're doing desktop stuff using web technology, but not for a web application that people come to via a browser over the internet. So Node is definitely a game changer in terms that it frees JavaScript from just running in the browser to running back on the servers, but because they solved that problem, it also meant it could run on the desktop as well and other locations. I mean, you technically can make it run on your phone. Another thing that shows up here, MongoDB. So we've had databases. We saw Oracle, MySQL, Postgres. MongoDB shows up, and it is basically built to store JSON. So this is the big JSON movement, right? It was spec'd out a long time ago, but this standard now says the browser has to have a JSON method. Okay, the services start changing from XML to JSON, and now we have a database that can actually store the JSON raw. So the term in database speak is no type impedance mismatch. The data is JavaScript, JSON, and when it's serialized as JSON by the browser, it can be stored immediately in the database and also returned that way as well. We could go right to the MongoDB database, bypass the services completely, and grab the JSON right out of there. Now, in 2015, right, still a few years back, right, the ECMAScript 6 lands, and that. Big thing here, there's probably two huge things that land that start to change things. The first one is the promise, right? So there's always an issue about the asynchronous calls, right? The AJAX way back. So we can still do AJAX calls today, but we typically hide them inside a promise. The promise makes it look much cleaner, right? And we can chain promises together, and they have a built-in catch in case something goes wrong. And so they're quite elegantly designed. Okay. Now, if you're using the ArcJS JavaScript 4 API, they do use promises, and a lot of the samples will have them. So if you're doing 3D and Web App Builder or using Experience Builder, then you can leverage this technique of writing JavaScript code that uses promises. If you're not in that area, then you're going to have to fall back. Maybe you can get by with a standard fetch. So fetch is a routine that the browsers must have, which is promise based, which you can go get data as well in that. But if you don't have access to those, then you're going to have to fall back to AJAX and doing XML HTTP requests. Now, there's a few things about let and const, different ways of defining variables. A little bit gets added to the math class, not big ones, but all important. But the big hit is the promise concept, and it's still alive and kicking today. Now, Typescript comes into play because much like Python, we can add type hints. They're optional. TypeScript's kind of the same thing. We can add type hints to the language. The language is not statically typed, it's dynamically typed. And so to give people hints while they're using code, we can add TypeScript to it or use TypeScript files. A big thing that happens but doesn't pick up traction right away is the ECMA module system. So this is how you can now do modules in JavaScript. So this is adding import like all the other languages, Java, C#, VB.NET, Python, right? Had a way to bring in modules by importing. This word now shows up in the language. And what's interesting is it takes a while for this to really, I guess, be realized just how different this can be. It does mean that you don't need to import the common JS libraries and do requires. The browser knows how to do an import in that. But although it's in the spec, it doesn't mean that every browser can immediately support it. They have to figure out a way of how they want to do that. And so there can be some lag, right? They get it in the standard, and then the browsers have to rush to support it, and how well they do that. And sometimes the devil's in the details, or the implementation details for sure. Other things that show up are the Electron Framework, which is kind of interesting. This is what frees Node from the backend sort of to the desktop. So we can use the Electron Framework to build desktop applications. And so the technology it uses is Node to interpret your code. The code you're writing is JavaScript. how you build the interfaces is with HTML and cascading style sheets, but you can build a web desktop application using web technologies. Other things that show up or have been worked on is as these applications get bigger and bigger, and this is really coming out of the required era, the whole fact that we can import code, things are getting bigger and bigger and bigger. There's more and more JavaScript, and these bundlers try to wrap your whole application up, typically into a single JavaScript file that gets fed to the browser. You might be pulling JavaScript from a whole bunch of different libraries, and bundlers like Webpack, Parcel, Rollup can then produce that one file JavaScript, or one file of JavaScript for your browser, and that's what actually runs. So they try to manage transpiling. Okay, if we have a bunch of different browsers, and maybe we have some really old browsers, and so they put in all the missing pieces so that your application has a hope of hitting as many browsers and behaving properly as you can. So Firefox, Opera, Chrome, IE, Edge, and even other browsers as well, and so the bundlers start picking up steam, and these bundlers actually the Electron Framework will change how you write a web technology-based application for the desktop. It'll change how you write the JavaScript, and so will the bundlers. The way you write JavaScript in these tools wouldn't work raw in a browser, because they handle all the importing / require statements for you. And so it is you'll see examples of code, and OpenLayers is good for this or bad for this, that they'll show you some sample code. Hey, here's how you get a map up on the web. But that, if you were to take that JavaScript and try to run it in a browser, it won't work. If you notice further on in their samples, you'll see that they run it through Parcel to actually bundle it. And that changes the JavaScript that you wrote and puts it in a format that is suitable for your particular browser, right? And one is because they know they're going to have to do that anyway. They can free up how you write JavaScript, but then you're writing JavaScript in a very different way than you would if you were doing it raw for the browser. And so you can, I guess, develop some bad habits that you have to be aware of. That the way I'm currently writing JavaScript, I couldn't just drop into the browser. It wouldn't be able to figure it out. And so what you run into is when you're trying to look for a sample, hey, is there someone who's doing something similar to what I'm doing? You can run into these samples that have a very different style. That's one issue. But you can also run into a sample that will never actually run directly in the browser unless you can find out what bundling tool or what framework like Electron they were using in that sample, because that can affect how you need to write the JavaScript code to get it to work. And you might hear a term called microservices. This is definitely the era of microservices, but Node has fueled that. Microservices don't have to be, but are typically or often written in Node in that. So Node helps you build a custom web server. A custom web server helps you build these microservices that are typically REST JSON APIs or front ends that you can talk to get data out of. So Node starts to really fuel this microservices era in the back end. And so there's lots of services and microservices happening out in the cloud. A big thing that happens in the databases, if we look at Postgres, is 2012 JSON text shows up as a way to store data in the database. We can then a couple years later, because text is big, JSON-B shows up, and so it's a binary version of JSON, and so it dramatically decreases the size that the JSON data takes when it's stored in the database. So this isn't a standard relational database. I mean, we can technically get Postgres to shoot out JSON and immediately inject that into the browser and have something happen. Now, the ECMA script goes under some changes here, and so instead of doing big releases every 4 or 5 years, they're going to release every year now. So the number of changes that happen are fewer. but they can get them out the door quickly. And so just a few things get added. The exponent operator, much like we have in Python, includes, does this collection or array and have this value. It's like doing in Python. A big thing that happens though is async wait. Okay, so async wait is just a different way to write asynchronous calls. We've been doing asynchronous calls way back, right? All the way back to XML, and we can do those with promises as well. Might not have mentioned that promises are asynchronous. And sometimes a promise, when you dig under the hood, it's using these async wait. Now, because we solved it with Ajax and we solved it again with promises, we've solved this a couple of times. Okay, so the async wait is just adding new keywords to the language. But basically, the asynchronous part we've been doing for a while, right? We just have these other words. And sometimes you will find that your code kind of gets too noisy and the promise way can look more clear or easier to read. It all depends what you're doing in that. But there is some competition between using the promise method, right, which has been around for a while, and the async wait method. Your code does get noisy in that. And it's just a different style of writing the JavaScript. But again, because this is part of the ECMA script, this async wait thing, right, the browsers support it. And so now we get to JavaScript present day, okay, 2021 in that. So we have lots of big front-end frameworks. This is things happening in the browser. And that. So we have React, we have Vue, we have Angular, we have Svelte. Another thing that's going to happen is that you'll see is that we have cascading style sheet library/frameworks as well. There's lots of them. Well, here I'll just mention Tailwind and Bootstrap. I've colored them differently to the ones above are about JavaScript. These are about cascading style sheet. Some of these frameworks let you plug and play whatever cascading style sheet system you want to use. Some are very agnostic, they don't care. We have one, or you can pick your own in that. Something that happens is, and this just happened in the last year or so, is snowpack and Vite show up. Because of the ECMA module system that was released, a while ago, now most browsers support it. And there's libraries out there starting to be written into this format. And the big change here is that you don't need a bundler and you don't need CommonJS required libraries to do it. The browsers on their own can figure out how to import the code. And so what that means is, from a development point of view, or spinning up a development server so that you can write or test some code quickly or debug an app and make some changes, snowpack and Vite, right, can spin up really quickly. They lean on the browser being able to do the imports, less bundling. They have hot module replacement, which typically means as you write code, whether it be cascading style sheet, JavaScript, HTML, as soon as that gets saved to disk, it gets shot into the browser. You don't have to sit there and refresh things or control refresh to make sure that these scripts got in there. So they automatically see your changes and shoot it into the browser. Vite takes advantage of the ES build system while you're developing. I think it uses rollup when you finally decide to basically wrap up a bundle for distribution to put into production. But while you're debugging and testing, you're kind of unbundled using ES build and that to figure out how to bring in all your libraries efficiently. And then when you finally decide, hey, this is a version we'll test to throw it into production for people to alpha beta test, or maybe it's a final release, I think, don't quote me, they might be using rollup to do tree shaking to get rid of code that you don't need, and then to make that bundled file much smaller. Other things that have just happened a year or so ago is the people over at Crunchy Data have released PG FeatureServe and PG TileServe. It's Go based in that, but basically it's like having a little REST JSON service. Because it's PG, it requires Postgres. And so right out of the database, you can serve map tiles with PG tile serve. So that's mapbox vector tiles, go right out into the browser. And that most mapping clients like Leaflet, OpenLayers, ECMA can handle mapping tiles. And so PG tile serve is a little server that just pulls them out of your database and just forwards them to the browser. PG feature serve is different. You can choose what functions you expose, but basically it's almost like you writing an SQL query in the browser, having it shot all the way back into the database, and then PG feature serve just pulls it out of Postgres, flips it into JSON, GeoJSON for you, and then shoots it back into the browser. A new product, Dino, has just arrived, which is a kind of a competitor to Node. This Dino has been built by the original builder of Node, but adding TypeScript out of the box and being slightly more secure and sandboxed in that. And one more thing that arrives in Postgres is not so much a new format, but making the ability to do queries that use JSON, select star from a column that has JSON and pull out some attributes, key value pairs out of some JSON stored in the database, becomes much more, I guess, easier or smoothed out in terms of a syntax in that. So better, easier to write JSON queries in the database. This helps products like PG tile serve, PG feature serve get data eventually out to the browser. And so the thing is, where are you going to land in this landscape? Who knows, right? And so just be aware of where am I, and where you can, try to leverage, right, the highest technology that you can. So definitely today, we can get in here and I think it's safe to expect that JSON is a data format that you will be able to get. Also, because the browsers support fetch, that even if some library you're using doesn't do a promise, you can use promises out of the box. So it's a great way to get the data. Now, if you're going to be at the level of building your own modules, you probably want to adopt the EMS import style of doing it. But if you're going to be developing, and you definitely want to be in these tools here, snowpack or Vite, with hot module replacement. And if you are pulling spatial data from the database, like Postgres, and you need tiles or you need to be able to query the database to get features, whether they have geometry not returned, and you want to set up a backend that probably has either PG feature serve, tile serve, or a similar technology for Oracle or MySQL in that. And then that way, if you can, right, if you can, while you're testing the front end and building your front end tooling, just have the data flying out of these products like PG feature serve or PG tile serve. I think it'll just make it easier for you to actually build your front end applications. Your data is going to be coming as JSON, and then what you're really just dealing with is front end issues, not so much back end issues. So that's about it. It's been a little bit of a long talk talking about this particular diagram, but this is the landscape of JavaScript development. And you can use techniques out of all eras, right, as you build an app, but where you can, lean on technology that can help do a lot of work for you, like adopting JSON as your data format, using promises for any kind of asynchronous call, and working in products like snowpack or Vite for rapid application development and debugging purposes. That's all for now.